Hello, this is Glen Langston at from the National Science Foundation with Evan and Sophie from the Green Bank Observatory in Green Bank, West Virginia. And we're now going to give you a second demo about GNU Radio, this time creating tones with our computer. And we'll use that as a next step on understanding how you can discover that there are fascinating things happening all around you that you can't see with your senses or detect with your senses, but you can detect with tools like a radio telescope.
All right, so I already laid out all the blocks that we're going to use, but I will still go and explain them. So the first one here is a signal source. Just creates a signal with a cosine waveform in float format, and you can see that these options here for frequency and amplitude are defined by these variables called slider and slider on. So those are defined by these option boxes right here. This is just a simple checkbox that says 1 if you check it on and 0 if it is off, and that will pretty much turn our signal on or off. And the frequency of our signal is going to be defined by this range box, which goes from 100 Hertz all the way up to 8,000 Hertz. So that will define the frequency of our source. And I'm just going to output this to a audio sync, which just sends it to the speakers on my laptop, and also to a Qt GUI time sync, which you saw in the previous video. It just shows the waveform amplitude over time. So I will go ahead and run this. And so we see our slider here, and this is our amplitude thing, and nothing's on because I haven't checked this on. But once I do that, then we'll get a waveform at 700 Hertz. And so we can play around with this. We can shoot this all the way down to 100 Hertz. And you can see it, the distance between the waves here increases. And also, I can't even hear that.
Yeah,
so it's too low for us to hear.
These hertz I'm seeing in this waveform is that wave per second or a cycle per second. So if we're at 100 hertz, then we have 100 waves per second. If we go up to 700 hertz, then we have 700 waves per second.
So I can hear 200 hertz, I think. Yep.
There's a little delay between clicking and hearing, but yeah, it just takes a second for it to get through.
And so you can see that every increment up we go in frequency, you can see these waves get shorter and shorter. They get squeezed in. And so we'll shoot this right up to 3600.
Yeah, so younger ears can hear higher frequencies than older ears can hear. We're stepping through the range all the way up to 800 kilohertz, and we'd like you to, when you get this, see this video and download GNU Radio Companion, to build this design and see what range you can hear, what the maximum is. So that's sort of an invitation for you to give this a try and learn something about yourself.
So play around with this tool, see where your minimum hearing range and your maximum hearing range are, and let us know what you find. Thanks.
And if you are really feeling like a scientist, you can try and figure out why we're having these cool little patterns kind of jumping around on the screen. Like there's more than one wave in
View.
And so send this right up to 8,000. That looks pretty cool.
Yeah, I cut off at about
Okay.